Imagine a perfectly smooth sphere with just 3 holes drilled into it. At first glance, a bowling ball seems like one of the simplest objects ever made, but beneath its ordinary appearance lies a remarkable feat of engineering. Some bowling balls cost less than $50, while others sell for more than $300, and that price difference isn't just about branding or marketing. Inside, they are fundamentally different. Their core is almost never perfectly centered. Their outer shell is made from advanced resin formulations, specifically designed to grip the lane. Their balance is controlled with incredible precision, often within just a few grams. Every detail influences the ball's trajectory, its speed, and even the way it strikes the pins. In reality, a modern bowling ball is much closer to a precision-engineered machine than a simple sports ball. Today, we're going to follow its entire journey from raw materials all the way to its very first strike. The story begins long before the factory. Before a single drop of resin is ever poured into a mold, engineers may spend months designing a new bowling ball. Because not every bowling ball is built for the same player. Some are designed to travel in an extremely stable path. Others are engineered to produce a powerful hook on heavily oiled lanes. Still others are carefully balanced to offer the perfect compromise between control and power. To achieve these very different characteristics, manufacturers rely on sophisticated computer simulations capable of reproducing a bowling ball's motion across an entire lane. Engineers modify the shape of the internal core, redistribute mass, calculate the radius of gyration, analyze moments of inertia, and simulate thousands of virtual shots before the first physical prototype is ever produced. The real secret of a bowling ball isn't found on its surface. It's hidden deep inside. This component has a name, the core. Contrary to what many people believe, the core isn't simply a heavy metal sphere. It often looks more like an abstract sculpture. Some resemble hourglasses, others look like light bulbs. Some are almost cube-shaped, others appear completely unbalanced. These unusual shapes are anything but random. They shift the distribution of mass inside the ball, dramatically changing how it behaves as it spins. The more sophisticated the core design, the more aggressively the ball can change direction when it reaches the dry section of the lane. That's what creates the famous hook, the spectacular curve that experienced bowlers rely on to maximize pin carry. Once the engineering is complete, manufacturing can finally begin. The material used to produce the core is usually a thermosetting resin combined with carefully selected mineral fillers to achieve a specific density. Each ingredient arrives separately at the factory. They are stored in dedicated tanks, automatically weighed and mixed according to an extremely precise formulation. A difference of only a few grams could noticeably change the finished ball's performance. The liquid mixture is then poured into molds. At this stage, it looks more like a thick paste than a finished product. Immediately, a chemical reaction begins. As the resin polymerizes, it naturally generates heat. Gradually, the material hardens into an incredibly rigid structure. Depending on the formulation, this curing process may take several hours. Once the reaction is complete, the molds are opened. The raw core finally appears, but it's still far from perfect. Every single core is carefully inspected. Technicians search for the smallest crack, the tiniest air bubble, or the slightest molding defect. An imperfect core could create an unstable roll or make the entire bowling ball unusable. Manufacturers also verify the density of every production batch to ensure consistent performance from one ball to another. Once approved, the core moves to the next stage. This is where the real magic happens. The core must now be positioned inside the future bowling ball, and this operation requires astonishing precision. Unlike an ordinary ball, the core is almost never installed exactly in the center. Its orientation is calculated to within fractions of a millimeter. Special supports suspend the core inside the mold, while the outer resin is poured around it. Even the slightest movement would completely change the finished ball's characteristics. Operators carefully verify its position several times before production continues. Next comes the manufacturing of what bowlers call the coverstock. In other words, the outer shell. This is the part that actually touches the lane, and it's just as important as the core itself. The earliest bowling balls were made from wood. Later came hard rubber. Then manufacturers adopted polyester. Today, premium performance balls are made primarily from reactive resin formulations, specifically engineered to interact with the oil patterns found on modern bowling lanes. This resin is prepared much like the one used for the core. Each ingredient is automatically weighed. Colored pigments are added to create the distinctive appearance of every model. Those beautiful pearl or marble effects aren't painted onto the finished ball. They are created naturally by blending multiple colored resins before molding. As a result, every bowling ball has its own completely unique pattern. No two balls are ever exactly alike. Once the mixture is ready, it is poured into the mold that already contains the suspended core. The resin slowly fills every empty space. Air is carefully removed to prevent internal bubbles from forming. Another curing process begins. For several hours, temperature and environmental conditions are carefully controlled. The chemical reaction gradually transforms the liquid resin into an incredibly durable solid material. When the mold is finally opened, the bowling ball exists for the very first time, but it still looks nothing like the polished product you'll find in a pro shop. Its surface is dull. Visible mold seams remain. Its diameter isn't yet perfectly uniform. It's far too rough to roll properly down a bowling lane. At this stage, it looks more like an industrial component than a piece of sports equipment. Each ball is then assigned a manufacturing identification number that allows every stage of its production to be traced. Before moving on, some manufacturers allow the balls to rest for several hours or even several days. This resting period allows the internal stresses created during curing to stabilize. Only after that does the precision work truly begin. The rough sphere is about to become a perfectly balanced bowling ball, capable of rolling down a lane with extraordinary accuracy. And that's exactly where the most fascinating part of the manufacturing process begins. At this stage of production, the bowling ball is finally solid, but it's still a long way from knocking down a single pin. Its surface is imperfect. Its diameter varies slightly, and every ball must now be transformed with a level of precision measured in fractions of a millimeter. The first operation is precision machining. Ball is mounted on a specialized lathe, where it is held securely between multiple support points. As it rotates, incredibly thin layers of material are removed. The goal isn't to change its shape, it's to make the sphere absolutely perfect. A difference of just a few tenths of a millimeter may sound insignificant, but at speeds exceeding 20 kilometers per hour, even the smallest imperfection can alter the way the ball rolls down the lane. That's why the machining process is carried out in several increasingly precise passes. Between each pass, measuring instruments verify both the ball's diameter and its roundness. Once the geometry meets specifications, another critical stage begins: surface sanding. Not every bowling ball has the same finish. Some leave the factory with a brilliant mirror-like shine. Others intentionally retain a dull, matte appearance. That difference isn't simply cosmetic. It directly affects how the ball performs on the lane. A highly polished surface allows the ball to skid farther across the oil before beginning its hook. A rougher finish grips the lane earlier, causing the ball to transition into its hook much sooner. To create these different surface textures, manufacturers use a sequence of abrasive pads with increasingly finer grit levels. The bowling ball passes through multiple rotating sanding stations that gradually remove every remaining imperfection left by the machining process. Depending on the performance characteristics the manufacturer wants to achieve, Sanding may stop relatively early or continue until an extremely smooth finish is obtained. Bowlers often hear terms like 500 grit, 1000 grit, 2000 grit, or even 4000 grit finishes. The higher the grit number, the smoother the surface becomes. Some bowling balls then receive an additional mechanical polishing compound. Within minutes, the resin develops a remarkable glossy appearance. Once again, this shine isn't just about looks. It changes the way the Coverstock interacts with the oil pattern, directly influencing how the ball moves down the lane. While surface finishing continues, another series of inspections takes place. Every bowling ball is carefully weighed. Official regulations set the maximum weight at 16 pounds, just over 7 kilograms. Manufacturers typically produce several weight options, ranging from 6 pounds for younger players all the way to 16 pounds for competitive bowlers. Weight, however, is only one part of the equation. The internal balance of the bowling ball is even more important. Since the core isn't uniformly distributed inside the sphere, engineers must verify several performance characteristics. Most bowling balls don't leave the factory with finger holes. The 3 holes everyone associates with bowling are drilled only after the ball has been purchased. Every bowler's hand is unique. Finger sizes vary. Palm widths differ. The distance between the thumb and fingers changes from person to person. Even a player's release style influences how the holes should be positioned. Someone looking for an aggressive hook won't have the same drilling layout as someone seeking maximum control and consistency. Inside professional bowling shops, experienced technicians carefully measure the customer's hand. They observe the player's delivery. Some even analyze the ball's rev rate and release angle before deciding exactly where the holes should be placed. At this point, the bowling ball is essentially finished. But before reaching its new owner, it undergoes one final inspection. Quality control technicians examine the surface one last time. They look for scratches, color defects, or even the slightest cosmetic imperfection. Each bowling ball is thoroughly cleaned before being packaged inside protective materials designed to prevent damage during shipping. From there, it leaves the factory. Some travel to sporting goods stores. Others are shipped directly to professional bowling shops. Some even head straight to international distributors before reaching bowlers around the world. Its journey through manufacturing is complete. Yours, however, is just beginning, because a bowling ball never reaches its full potential the moment it leaves the box. It only comes to life in the hands of a player. As the bowling ball leaves the bowler's hand, it first glides smoothly across the heavily oiled front section of the lane. For several meters, it appears to travel almost perfectly straight. But as the oil becomes thinner, the reactive resin Coverstock begins gripping the lane surface. That's when the asymmetrical core truly comes alive. Rotation accelerates. The axis of the ball migrates. It's the result of thousands of engineering decisions working together. Behind every strike lies months of research, countless computer simulations, precisely controlled chemical reactions, advanced metrology, and the expertise of engineers, chemists, machinists, and quality control specialists. So the next time you watch a bowling ball rolling down the lane, you probably won't see just a sphere with 3 holes anymore. You'll see an object engineered to exploit the laws of physics with astonishing precision. A product where every gram, every millimeter, every material, and every manufacturing step has been carefully optimized for one purpose: to send 10 pins flying with absolute precision.